everyone. My name is Hannah Nye. Thank you for having me here today. And to get started with this talk, I just wanted to ask a couple of questions to you guys. So the first one is, who here is a UI or UX designer? Just to show of hands. Okay, awesome. Who here is working on XR projects right now? Okay, most of us, awesome. And then the last question is, who here is having a difficult time with XR design? Okay, awesome. So I'm hoping my talk today will help you out. All right, so just a quick timeline of visual language and technology. At the top left, you can see that we started with binary language, right? Our ones and zeros. We had computers that filled entire rooms, and that's kind of where we started with our visual language because that's where our technology was at. In the middle picture you see there, we eventually moved on to better technology, and that meant a better visual language, which was programming languages that we had. So the example there is like a terminal, basically. On the far right at the top, we have the example of the Macintosh that was released in 1884. We all know that Steve Jobs took the amazing trip to Xerox, and he came back with some cool ideas, which we today call the WIMPs, right? The windows, icons, menus, and pointers. So over the past 25, 30 years, we've really had a chance to design and really create those 2D principles, and the iPhone that you see here is that idea now, that we've really created a great paradigm for 2D UI. So today we now have XR technology, and how does our visual language change to that? A lot of what we've been using is the same 2D UI design, when really we should really start to be looking into better design that works with our new spaces and our XR realities. So about me real quick, that's what I actually look like in real life. I went to the University of Tampa for new media design for my undergrad, and I quickly started in web design and interaction design, so working in 2D spaces. And then I started to work in some animation and video production, so I kind of got an idea of how to create storyboards, work with scripts, and take B-roll and shoot B-rolls with my team. And then I went back to the 2D UI design, really understood what those principles meant, and for the past 2 to 3 years, I've been working in XR design and researching that. So when I started researching, I started in basic UX design principles, right? For user experience design, we have 3 main pillars: utility, usability, and desirability. And all of those principles lead to a process that we use. So I figured that if I start with those 3 principles, that it'll eventually lead me to finding the new XR principles that could live under there. And through my research, I found quite a bit under there, and that's what we're going to talk about today. We're going to talk about how XR has changed these principles and has created a new process for us. So starting with utility, those are our 3 main topics under there. Why XR? We start with our projects, and we really need to look at what's the goal for XR. What's our goal for our project? Why are our users using it? Is it useful to our users? And then after we have that and we understand that, we move on to who is our user? Why are we creating this system for them? And what do they need out of this system? And then one of the more important questions for XR is, does this system even need to be an XR? If it doesn't need to be an XR, and if we don't provide a system that works well with XR, then it's not even usable, it's not even useful, right? The utility. So when we look at whether this project or system needs to be living in XR, we need to understand what the context is. So if we're working in AR, that means that we need to realize that we're integrating a whole new system into our real-world space, and it has to make sense. It has to work with our real-world space. For VR, there needs to be a reason of why we're taking somebody and putting them into a whole different world, because they're not in this real world anymore, and there needs to be a reason for that. So to our first example, contextualizing the user space. This is an example of a concept design that we created for a company that we worked with where their users were out in the oil rigs and they needed navigation to lead them to where they needed to go. At one point during their navigation, they needed to know if they needed to put on gloves at a certain point. So in traditional 2D UI, we'd probably understand where they are, we'd give them a GPS, we'd understand their GPS location, and provide them a pop-up that said, hey, put on your gloves now. And we wanted to take that a step further. We wanted to contextualize and really work with the AR space that we've provided them. So we provided them an icon at the exact location in the world where they would need to put on these gloves. And it really worked for them. Another example of contextualizing the space and you really working with your area, this is a project that we're working on right now called Augmedic. It's for the military. It teaches tactical combat care for soldiers who are out in the field, so basic health care. And the first thing that we did was we provided them with a video that taught them how to work with a tension pneumothorax, which is the collapsed lung. So you could see there's a fake mannequin there, and there's a video that they would watch, and they would watch the video and then perform. Immediately after we created this design, we realized that it didn't take advantage of the space. We didn't take advantage of contextualizing based on the real world. So because we always knew that the user would have a mannequin in front of them, we decided to take it a step further. Instead of making them watch a video, we provided actual lungs or virtual lungs on top of where they would actually be on the mannequin. And now they can learn that way instead of just watching a video in space. So it makes much more sense with the space. And that's the tagline that we try to really come back to every time we create something in a space. The system must be designed to support the human in performing tasks in a particular context. So the last thing for utility is we need to determine the tech. What is the best XR technology to use? And the only way that we'll know that as UI or UX designers is by using the technology. If you're creating designs for the HoloLens and you haven't touched it in over a month, you need to be using that daily, at least weekly, to really know how users are experiencing the HoloLens. And an example of a question that we always ask before we start creating a project, a really simple one is, does the user need to see their body? That's going to determine your tech, and you can tell by the scope of your project of whether you can create body limbs in VR, and if you can't do that, then take it back to AR, and you can let the user see their body and work from there. Moving on to usability. So usability is simple. It's basically, is the system usable for the user? Do they know where the exit button is? Do they know what their next steps are? Do they know how to get around this navigational space? And that's an example of Beat Saber, which I think is a really great example. Users know almost immediately what they're supposed to do, so it is very usable. So talking about space, we need to consider the space to make it a usable system. And we have two types of space. We have the world space, and we have the user space. So let's take a look at an example of a really great use of world space. This is a video of The Void, and if you don't know what that is, they're a company that creates world space within a building. They basically set up the location, and then you go into a virtual lens, and you get to see and experience that world in a virtual reality. So just play this. So yeah, that's a really great example of using your world space and putting that virtual reality into the world. So these are the 2 points that we need to think about when we're working in world space. What is the first one is size. What is the size of the space that the user is working in? Are they in a bedroom or are they in an airplane hangar, right? The size difference really needs to change. The UI has to change to where they're in. And there's two ways that we can do that. We can create user-defined boundaries. A lot of VR products are already doing that already, right? People put on the headset and they draw the lines of where their boundaries are, and we let them know if they get close to those boundaries. So that's one way to do that. Another way is to know the space that the user is in. If we can know that they're in a smaller bedroom by scanning their area, we can create dynamic content for them. We can create dynamic UI for them. So the best way to think of that is like a website, right? If you're working on a huge monitor, you have a different design. And if you're working on a little mobile phone, it's a different design, and we're dynamically changing that design to provide the best experience for the user. And so that's the same for space. The second principle to think about is external factors in space. Is a user working outside? Are they working inside? Is it raining? Is it bright all the time? Are they always looking at water for some reason? Because we need to be able to work with all of those things. So let's look at some examples of how we can work with that. So the project that I mentioned earlier, Augmetic, we were able to do some user observations and see where our user would be using the system. So we sat in a classroom setting where the military users were learning about their tactical combat care. And the first thing we realized is that we wanted to provide them with a life-size Humvee in this classroom. And unfortunately, that classroom space was really small. If it was one user, maybe they could walk around and check out the Humvee and see what it looked like. But in the end, we want all of those users to be able to wear a HoloLens at the same time. And if you can imagine putting a life-size Humvee in that room and having all the users walk around it at the same time, they're going to start bumping into each other. So it's great that we went and we observed our users, saw what their space is, because now we know it would be really cool to provide them with a life-size Humvee, but it's not practical for their world space. The second example of external factors, on the right there you can see an image of a colleague, Nate Hatfield. He went out with us to do some user observations, and we immediately realized that when they're working outside, they do that for almost 2 days straight. One of the days that we were there, it was raining all day, and they had to work outside. And the second day that we were there, it was bright and they were running around. So immediately we realized we're working with the HoloLens system, so that means we can't work outside in bright environments, right? They're not going to be able to see these virtual realities as well as they would be able to inside. And the other thing with the raining, I mean, any technology outside in the rain all day probably isn't going to work that well. So we decided actually not to provide them the system if they're working outside, and it's better to not provide them an experience than to provide them a frustrating one. Moving on to the user-centered space. The diagram that you see up there is provided by DreamWorks, and what that really says is that a lot of people are using this type of user space information. There's 3 areas for the user space. The first one is the personal space. This is within your arm's reach. This is where you can move your arms around. Maybe you're touching things in your space. You're not really walking anywhere. So in this area needs to be physically open for the user. There can't be a chair next to them, and we need to be able to tell them that or know that and work with them. And then the second thing is that critical information likely needs to be placed there. If they need to see anything immediately for whatever reason, that'll be in this personal space. The next area for the user is their action space. This is the area that they might be walking in, or they might be throwing things. So this is kind of their immediate area outside of their personal space. And again, this is the area that you would provide obvious area boundaries. The last space is the Vista Space. So this is anywhere that's about 30 meters out. That's kind of a general rule. And there's very limited interaction zone. We can't expect users to be working in this space at all. And things that we need to create for UI UX design is that objects need to look further away, right? We have to make sure that things that live there that are virtual make sense to live in that space. If there need to be dust particles to make sure that they know that things are further away, then we have to provide that. The next principle for usability is navigation. we're putting these users in a whole new world or adding on to their world, so we have to provide them navigation to move around those spaces. So examples here are virtual landmarks that you could see at the bottom right. That's the pole that you see. They work just like real life landmarks where people know where that is and they can move around it and know how to move from there. We can also provide them distant counters to their next waypoint, and that's a really good way so that they can know how far they need to actually walk in real space. Mini maps, this is something that's very common in video games, but we can use this in our XR headsets too. And then also providing, and also by knowing the user, we can provide them with virtual overlays to improve their safety. So if they need to be walking upstairs, we need to know that that's going to happen. We can take away some of that navigation so it's not getting in their way so they don't fall or trip. Okay, so the next principle for usability is affordance. So what does that mean? Basically, that to me means that the user knows that something is interactable. If they know that something is interactable, that means that you've provided affordance. And we need to provide affordance with anything that they can interact with, right? The users need to know this. So we need to know our users. Do they inherently know that something is interactable? For a person who's never seen a piano before, would they even know to press those keys? Possibly not. So we have to provide those. We need to know our users. And here's an example of the piano, someone that does know.
Ooh, thank you, Alfred. Very good. I have a key. Oh, the piano! So can I play this? I can't play the piano. Whoa!
So you can see he knew immediately he could probably play this piano. By knowing our users, we can provide them with great affordance. Okay, moving on to desirability. This is our last pillar of UX design. We can provide a couple things for them. The main thing for desirability is we want them to experience presence. That's what's in the green there. By creating engagement, that'll lead to immersion, and we can get them into presence. And why is presence important? Presence is important because people willingly believe that they are in this new reality that you provided for them. They don't even have an inkling of distrust that they aren't in this reality anymore, and they've completely accepted it. So how do we do that with all of these things? The first one for engagement is we need to provide users with an activity loop. We have to get them engaged and keep them engaged in the system. Once we have them engaged in the system, we can provide them with immersive interactions. So we can provide them with symbology, we can provide them with novel interactions like magic, and we need to provide them with natural interactions that are similar to our real world interactions. And once you have engagement and immersion down, that'll lead to presence only if you have meaningful information for those users. Let's look into engagement. These are some of the models that we found in the research that are available already. And we took these models and we created our own model of engagement. And this is a bit to get into today, so I'll kind of go over the main points from this new engagement model. The idea is that we start at a point of engagement for the user, we engage them, we get them into this activity loop where they do some kind of activity, they have an accomplishment, and they have some kind of feeling or effect. And then eventually, they might get disengaged from the system. That's either because of time or they were frustrated by the system for whatever reason. So we kind of want to avoid disengagement, right? We want to keep them in that loop. And the two main points that I want to take away for this for XR is that at the point of engagement or re-engagement, we have to know our user and we have to keep them intrinsically motivated. And I know you're thinking we can't provide that. So the only way that we can know what their intrinsic motivations are to know our user, to do our user observations, and to build our system for that user. And the second point that we need to think about for XR is that we cannot have an absence of meaningful information. That's when disengagement happens, right? And when you're thinking about your end goal, which is presence, you have to provide meaningful information. And again, it's all about the user. You have to know who they are and what's meaningful to them. So let's look at an example of meaningful information. Let's say that you create an AR app that allows users to pick up a dress or some piece of clothing and try it on, and they're able to see it in a virtual mirror. If your user was Arya Stark, for example, she thinks that this new system is pretty cool. Technologically, she's never seen anything like this in Winterfell. And sorry if you don't know Game of Thrones, she basically is not really interested in clothing. That's, you would probably know that about her. So she thinks that this is a pretty cool technology, but at the end of the day, she's never reaching presence. She might get engaged, but this isn't meaningful to her at all. She doesn't really care about this kind of stuff. Now let's say that you made this system for Sansa Stark, season 1 or 2 Sansa Stark. She's really interested in this system. She's totally engaged. She's been immersed because there's natural interactions happening, and she's reached presence, and she wants to stay in the system for forever. She wants to try on all these clothes. That's just her personality. So this is why meaningful information is so important. When we know our user, we can build this system for them. And just by observing these two ladies for about an hour, you would immediately recognize that, and you'd be able to say that this would only work for the user on the right. The next principle for desirability is natural interactions. And this just means that we need to be able to replicate what we do in the real world in our virtual or augmented environments. So that's an example of leap motion. I mean, that's a great example of natural interaction. You're plucking petals like you would in real life. And what's great about natural interactions, especially for VR, is that it's going to lead to embodied perception, where you believe that these virtual limbs or pointers are actually part of you, and that really gets you engaged, immersed, and will lead to presence. And the last thing for desirability is perceived user control. We need to give users the ability to choose what they want to do next. Decision making is a huge thing for users. So an example here, if you guys have seen this before, this is from Netflix. It's called Bandersnatch. It's an interactable video where you choose what you want to do next. And just by giving users these two simple choices, users were really engaged with this product. And of course, there was great storytelling. And then we also need to give users control over the inconsequential. They can have the option to choose things, but what about just providing them data? Uber and Lyft, they provide great data about where your driver is at the moment. You know exactly which way the car is pointing on what street and how far they are until they reach you. A user isn't doing anything here, but they feel in control because they have all this information in front of them. And this is an example of a 2D UI, but we can bring this into our 3D UI design, or XR UI design. Okay, so with all these principles, this is eventually going to lead us to a process. The first thing that we realize at Design Interactive is that audio is half of the experience, so we can't forget to input that into our designs. And here's an example of audio. So obviously, just by taking out the background audio, it completely changed the mood of what was happening from kind of like motivational to kind of comical. So here are just some quotes, right? Audio is so important. This is from game designers and famous directors. But if it's so important in our 2D UI and our videos and everything like that, then we need to provide it also in our XR design. So how do we do that? When we're UX designers, we're not audio designers. How do we start doing that? The thing that we could start looking at is how do we want the user to feel at certain parts in our design? What is the mood that we want to give them? What do we want them to feel? And as we start to look at that, you can match that up with your wireframes or user flows or whatever it might be. You'll start to see that there's a symbolic language that you could start to create for the user. Once they get to the menu, they hear this certain sound and they start to incorporate that and they start to make they start to match that up. So the next step in the process, once we know that audio is so important, is that we want to start looking into creating scripts. So we still want to do the typical user flow design, which includes the user goal, which we found out from utility, the task flow of the user, wire flows, and some kind of interactable design, maybe a prototype. But if we stop at the task flow, we can really see that we can start to branch out into one use case that will lead into a script that we can use to eventually create a video storyboard. So an example of a script is this one here, and this is just a typical script that people use for video design, right? So this is what you can start using once you've created your task flows and use cases. On the left, you'll want to talk about the visual. What is the user seeing at the time and where are they looking maybe? In the middle, you want the audio. What does the user hear? What's the conversation design that's happening? What is the user saying even maybe at this point? And then on the right, it's not here, but we want to start incorporating how is the user interacting at this point in time. So you kind of create a script timeline that you can start to work off of to showcase what the design is going to look like. And this is an example of an animated storyboard from Toy Story, which is what we're going to try and start to get to.
Let's all be nice and say hello to our new friend.
Mission log starting 4072.
So this animated storyboard works really well for a couple of reasons. One, we know exactly what the user is seeing at that moment and we can account for it. And then two, we know exactly what the user is hearing. We hear the audio that is being said by the characters, and then we hear the background audio that starts to create that mood that we talked about. So this leads us into video storyboards. This, I believe, is the next step for creating XR design. This is our process that we need to start using. We need to know what is the user seeing right now, right? Just like that animated storyboard, we need to know what the user is seeing, what they're hearing, how those audio and visual designs are making them feel at that time. And the best part about this is that we're going to be able to provide this to our teams and get them on the same page much quicker than showing them either a wireframe or just a 2D storyboard. So I want to go through the process with you of something that I created recently for Augmetic. The first one that I want to go through is a 2D storyboard, a traditional one that describes what's happening frame by frame. And then I'm going to show you in contrast the video storyboard and how much that changes things. So bear with me as I kind of read through it as I would to my team. So Augie, in our first frame there, he's our voice of reason. He's like a Siri or an Alexa. So that's who Augie is, just for your information. So Augie says, "Hi there, I'm Augie." He starts to explain that you're going to be learning about tactical combat care. You maybe hear a startup sound at this point, and you see an animation of the Augie speech come up in front of you. In the next frame, you hear Augie say, "To get started, press," or say, "Start scenario." You see a button appear, and you see some animation, and the interaction at that point is the user can either press the button, or they can say, "Start scenario." And the last frame there, Augie says, in the theater of war, tension pneumothorax is the second leading cause of preventable death. Right now we start to hear some war and military music, maybe with like a drum line in there, and we see a video of military members in the field playing. The next frame says, accounting for 33% of all primary causes of preventable death. You kind of see a pie chart flow up. You see 33% appear, and you still hear that military music happening. And the next frame, Augie says, if not identified and treated promptly, and immediately a heart appears over where the mannequin would have a heart, all right, that's a real life mannequin, you still hear the war music, and you start to hear a heartbeat sound. And the last frame there, he concludes with shock and cardiac arrest may occur. You still hear military music and you hear a heartbeat sound. And then he says, I've uploaded a virtual collapsed lung in front of you. And you start to hear pleasant music now. So now it feels a little bit better, the mood's changed. Lungs appear on top of the mannequin. And he says, take a closer look at it by rotating and enlarging it, and you see some virtual hands start to move. And you still hear this pleasant music. And Augie shows you how to rotate, and that's the animation for that frame. And the last frame there, Augie doesn't say anything, but the user is starting to interact with the virtual lung. So that was a long-winded explanation of a 2D storyboard, and now let's see how a video storyboard changes that.
Hi there, I'm Augie. I'll be here to help you learn about TC3, Tactical Combat Casualty Care. To get started, press or say Start Scenario. Let's get started. For this scenario, we're going to learn about a tension pneumothorax. In the theater of war, tension pneumothorax is the second leading cause of preventable death, accounting for 33% of all primary causes of preventable death. If not identified and treated promptly, shock and cardiac arrest may occur. I've uploaded a virtual collapsed lung in front of you. Take a closer look at it by rotating and enlarging it. As you can see, air continues to accumulate in the pleural cavity and increases pressure on the injured lung.
So that's the contrast between the two, and I think it's almost immediately apparent the differences. When I show my team a 2D storyboard, there are a lot of questions at the end of it, and there's a lot of explanation. But as soon as I showed them this video storyboard, they were immediately on board. They knew exactly what was going to happen, and the developers almost were able to take this video and start creating immediately. There were no questions asked. And this only took me, I made the same sketches for the 2D and the video storyboard, and this only took me a day to put together just some animation, some audio I found, and to record my own voice as Augie, the speaker. So after you've created your video storyboard, maybe you need to test out spatially if this design is even going to work. So these are examples of us testing out spatially some designs. At the top left there, that's my arm. I was testing out how some designs were going to look if they were placed over actual arms. At the top right there, that is our XR developer, Eric Martin. He was testing out the idea of using a light to shine to capture the user's attention to see how that would work. We basically taped a flashlight onto a hat, and it worked really well. And then at the bottom left, that's just the concept of attaching designs to real-world objects and how that might look. And at the bottom right, that's me. I was testing out the idea of using these virtual or goggles to see what their field of view looks like without actually having to go into a HoloLens or some other headset. Okay, so now I want to do something a little different. I want to ask my colleague on stage to kind of show you these very practical spatial layout tests. So a round of applause for Ed Cross. So the first thing we have here that you can see in this picture is the glasses, and basically they block out your vision as if you were wearing a virtual headset. So Ed, what can you see right now? How is your view limited?
I can't see my hands, now I can. So now I can't, now I can.
Right,
and
so.
Now I can't again. So very much like the HoloLens.
So just by making these glasses, we were immediately able to test that. And from standing there, imagine that this is your menu or buttons that you need to access, and that they lived here next to you. Tell me when you can see them.
Okay.
If you look this way. Yeah, eventually.
Oh, there it is.
Now you can see them. Okay, awesome. So that's great testing. So maybe that's not going to work. So let's say if you walked over here and this menu lived with you. How does that?
I feel very uncomfortable.
All right, so we knew immediately just by testing that this doesn't work as well for our system. And then we came up with this design of a radial toolbar. So go ahead and put that on. Our menu now lives in a couple buttons here and a toolbar that lives around you and follows you around. So how does it feel now?
Really goofy.
Is it visible?
No, I cannot see.
No, you cannot see. Okay, is it too low? Is that?
Yes, very
Okay.
close, yeah.
So what if we brought this up a bit?
Yes, now I can see it. Yeah.
Okay.
But it's
So
very close.
very close. All right. So immediately we knew that this system, this menu design needs to live at a certain area of the body for the user. And this might work a little bit better than a menu that lived in the space or followed you around. Okay, all right, thank you very much. Round of applause for Ed. So I wanted to show you guys that because it was so quick to grab a couple of pool noodles and just quickly make the design concepts and test them out with people in our workspace to see what they thought about it. And here's the result of creating that toolbar in space. So this saved us a lot of time of having to create all those different menus. We were immediately able to go straight to the design that we tested physically. All right. So what if you don't want to test spatially with arts and crafts? What if you need to go deeper into actually testing out your virtual assets? Here are a couple of programs that we use in Office. We've tried out Microsoft Maquette. That's a virtual reality system that you wear with the headset. You're able to look at some tools on your wrist and put them in the environment. And that's really great to test out spatially how things are going to live. On the right, that's one of our own tools that we have called Augmentor, maintenance training tool. And basically, we're able to upload some UI designs on our web portal and immediately get it on the HoloLens to see how it's going to look in space to get that spatial awareness. And on the bottom left is another system that we use called Wireframe. And this is great because you're able to upload some of your own content and test out how things are going to interact with each other and see if there are variables that you can add in there and see how that really works. So getting back to our timeline, we've made it so far from binary code up to 2D UI, and now we're at XR technologies. So we have all of these principles, we're starting to design things, and I think that as we start to share these designs, as we start to prototype more, that eventually with time, we're gonna be able to get to where 2D design is now, but for XR design. And we're gonna have a whole new XR paradigm for design. Thank you.